Hello, I am Krish Dahake, a third semester section A student at Symbiosis Institute of Technology, Nagpur. I will be presenting Dijkstra's algorithm. So let's start. Introduction to Dijkstra's algorithm. Dijkstra's algorithm was invented in 1956 by Dutch computer scientist Edgar Dijkstra. It is a fundamental algorithm in computer science used to find the shortest path between two nodes in a weighted graph. It is widely applied in various fields including navigation systems, network routing, and finding optimal routes in transportation. Dijkstra's algorithm is basically a shortest path between two nodes or a shortest distance between 2 points. If we see the example, the most famous example for this is Google Maps. As the Google Maps shows us the shortest distance between two locations. It is the best example for this. Then we move to next slide. Understanding weighted graphs. Nodes. Nodes represent location of points in a network. Then edges. Edges connect nodes and represent connections between locations or two nodes. Then weights. Weights represent the cost or distance associated with traversing an edge, providing information about the relative importance or difficulty of each connection. Then how it works. Set initial distances for all vertices, 0 for the source vertex and infinity for all the other. Choose the unvisited vertex with the shortest distance from the start to be the current vertex. So the algorithm will always starts with the source as the current vertex. For each of the current vertex unvisited neighbor vertices, calculate the distance for the source and update the distance if the new calculated distance is lower. We are now done with the current vertex, so we mark it as visited. A visited vertex is not checked again. Go back to step 2 to choose a new current vertex and keep repeating these steps until all vertices are visited. In the end, we left with the shortest path from the source vertex to every other vertex in the graph. So here is the example in the diagram. So we have to move from D to F. So let's initialize that initialize 0 for the source vertex, and all the other vertexes should be infinity. So from 0, that is D, we will move to A or E. From D to A it is 4, or D to E it is 2. uh, from D to E 2, that is minimum, so we will move to E. Then from E we have three paths, 4, 4 or 5. So we will move to 4, but so we will move with the 4, that is we will move to C, E to C. Then after moving to C, we will have three paths, that is 5, 2 or 5. The shortest one is 2, so we will from C to we will move to B, and then B to F. It is the shortest path, and we have it is the shortest from D to F. We have to find all the paths like that only by going one by one. We can't move a vertex twice. It is not allowed. So that's how the Dijkstra's algorithm works. Example. Then this is the pseudo code for the Dijkstra's algorithm. You can see it. Then this is the code for Dijkstra algorithm. In this, there is a graph. There is a graph in which we have to find the minimum distance between the starting and the ending point. So here we will apply the functions, and we have to uh, take void Dijkstra here, and you can go through it. This is the output for the program. Then complexity. And the best case for time complexity is O of E, where E is the number of edges. This case comes when the we find the shortest point at the second point only or first point only. That is the best case. Then the average case is O E log E, where V is the number of vertices representing time needed to process edge and update distances. Then the worst case is O of V square. where E is the number of vertices. If the graph is so diverse, then the worst case can apply. So then limitations of Dijkstra's algorithm. The limitation is that negative weights can't be there. Like Dijkstra's algorithm doesn't work correctly with graphs containing negative edge weights. Then dynamic graphs, it is not efficient for dynamic graphs where edges and weights change frequently. Then large graphs or diverse graphs, it for extremely large graphs, the computational cost of Dijkstra's algorithm can be significant, leading to performance issues. Then applications or real world examples. Applications are navigating systems, network routing, transportation. It is the best example of the best real world example is the Google Maps, in which we find the shortest distance between two locations. Then Dijkstra's algorithm also works with the help of greedy algorithm. Then it is a very good algorithm for finding the shortest distance between two points or locations. That's all about Dijkstra's algorithm. Thank you.